My name is Oluchi Ukebu, and this is my video on the issues with multiple comparisons. Um, and this is for the HPA 472 Clinical Research Methods Statistics course. We'll first start by discussing and reviewing the statistical hypotheses and errors. So normally when we perform a test to compare two different means, a null hypothesis and an alternative hypothesis are formed. The null hypothesis will state that there's no difference in the two means, while the alternative hypothesis will state that there is a difference between the two means. And then for each test that's performed, so one test in this case to compare the two different means, a p-value is a p-value is assigned for that test. And the p-value is just stating that what the likelihood that there's going to be an alpha that alpha is present, meaning that there's going to be a type 1 error or a false positive error. And then normally the p-value is usually set at less than 0.05, and that's just saying that there's a 5% chance that the data will show something that is not really there. So when we get towards the when we start comparing more than two means, and that's when we kind of fall into that's kind of when we fall into the trouble of increasing their likelihood of having more false positive errors. Because if we have, so say for example, we add on another mean to compare. So now we're comparing three different means as opposed to two different means. Then that means three tests are performed. If three tests are performed, then we now have three new p-values, one for each test that's performed. And the fact that we have three new p-values increases your likelihood of having a false positive error. This can be mathematically explained um, by by using the equation 1 minus alpha to the k. And then so in this case, for example, so say we use an example, sorry, for 10 different means. And then so we're trying to compare 10 different means from, we're trying to compare 10 different means. And normally, if we are assuming that alpha equals 0.5, 0.05, sorry, then the probability that there's an observed difference between two groups is not due to chance variability is 1 minus alpha or 0.95. But however, if you start making 10 comparisons, then the difference, the probability that an observed difference is true is no longer 0.95. It actually becomes 0.4 because you need to simply by the equation of using 1 minus the alpha to the 10th, and then you start getting 40% of zero point 0.4. So when you're if 10 comparisons are made, then the time one error rate increases to 40%. So now you have a 40% chance that the data will show something that is not really there. And so you see, when you're using comparisons, when you're trying to compare more and more groups, the more and more groups that you compare, the more and more chance you have to have a type 1 error rate. And so that's why we like to instead use the analysis of variance or the ANOVA to compare means of 2 or greater. And so that's what this week's assignment will be on. And so refer to the lecture notes and the chapter 24 to learn more about the analysis of variance.